guys. Back with Miss Elsner from the Maricopa campus. This is lesson 86, Algebra. We have some new formulas that we're going to learn today. Please make sure that you have your notes open, your book closed, and follow along with me. So let's make sure that this is focused up on the screen. And get this written into your notes. This is lesson 86. We're calculating the midpoint and the length of a segment. Midpoint and length of a segment. Two new formulas that we use often in geometry. You're going to see these a lot next year when you move on to geometry. Okay, our objective today, students will be able to analyze distance and midpoint between points by discovering the distance and midpoint formulas. All right, so to get started, yesterday's lesson was talking about the Pythagorean theorem, and today we're going to start with the Pythagorean theorem, which is kind of nice. So we know that if we have a right triangle, which is what we have in this diagram, and this would be our right angle right here, we can use the Pythagorean theorem in order to find distances. We have the diagram shows a grid of city streets. A car travels from point P to point Q by moving east to point R and then south to point Q. What is the direct distance in city blocks from point P to point Q? I feel like that question sounds kind of confusing, but it's actually quite simple since we know the Pythagorean theorem. So what you want to do is, since we've determined that this is the right angle here, we're just going to use our a squared plus our b squared in order to solve. And in order to figure out what the numbers are, you're just going to count spaces here. So this would be 1, 2, 3, 4. This would be 1, 2, 3. Now from this line to this line, I can't count because you see it's going in on a diagonal. So I'm going to use my Pythagorean theorem. Okay, so I'm going to do it on my computer here. I've got a squared plus b squared equals c squared. Okay, remember I said this one was 4. So it's 4 spaces. This one is 3. Hopefully you can see it on there. And I'm going to say 4 squared plus 3 squared is equal to c squared. I see that 4 squared is equal to 16. 3 squared is equal to 9. 16 plus 9 is equal to 25. And then I've got to take the square root of each side. And I will get c is equal to 5. Okay? Alrighty. Little review from yesterday. And here's our new concept for today, and I'd like you to get this down in your notes. This is brand new. This is something called the distance formula. So make sure you get that in your notes. Distance formula. Distance is going to be equal to the square root of the difference of the x's squared plus the difference of the y's squared. Now what that subscript means is we're going to look at the points that we're trying to find the distance from. Okay, so you're going to take the second x, which this would be if I was saying that this was my first point and this was my second point. Okay, I'm going to take my second x and I'm going to subtract it from my first x. I'm going to take my second y and I'm going to subtract it from my first y when I'm sticking them in that distance formula. Okay, so make sure you have that down in your notes. And moving on, we're going to use it. Oh, this is a great slide too. Remember that this is a lot of subtracting, and we're also going to have some negative numbers in there. So make sure that you remember when you are subtracting from a negative, and we've been practicing like this ever since 6th grade, we need to add the opposite. So I don't know what you use with your teacher when you're talking about subtracting a negative, but we use algebraic addition, and we're going to add the opposite. Change that sign into an addition, and you're going to take the opposite of the next number. Okay, so essentially you're adding them. Oops, did not mean to do that. And technical difficulties. Okay. Next up, we have find the distance between this point. We're going to say that this is our first point, this is our second point, and you're just going to stick it into that formula that you just wrote down in your notes, which is the distance formula. Okay, so remember that we wrote d is equal to a big old square root sign. We want to take the first x, subtract from the second, square it, and then we've got the second y, and we're subtracting from the first y. Okay? All right, so I'm just going to use, like, this is my first one, this is my second one. So when I substitute those in, I've got 6 minus 3 squared plus 4 minus a negative 2 squared. Okay, like in a reminder, we have to go through and I'm gonna change it right now. This guy right here, I don't like how that's written, so I'm gonna add the opposite. So you're essentially gonna add them together. So add the opposite, it makes it much simpler. 6 minus 3 is equal to 3. And we need to take the square root, or square that. And then 4 plus 2 is equal to 6. And then we're going to square that. Don't forget to keep your square root sign there because we have to do that as our last step. All right, 3 squared is equal to 9. And 6 squared is equal to 36. If you add those two numbers together, and I'm getting kind of low there, so I'm going to work off to the side. I've got 9 plus 36 is equal to 45. Remember, we're taking the square root. And rather than coming up with a number, the square root of 45 doesn't have a perfect square. So what we're going to do is we're going to figure out what is the exact answer, but we want to put it in radical form. So I know that 9 times 5 is equal to 45. So got 9 times 5. The square root of 9 is going to be 3. And 5 doesn't have a square root, so we are just going to say 3 times the square root of 5 as our answer. And circle that so that you can see which one it is, because I kind of had to go sideways there. I was running out of space. But that is the distance formula. The distance formula. Okay. Next up, we have a practice with a geometry problem. So we're going to talk about, you need to know that a rhombus, and I think that you know this already, but get it down in your notes anyways. A rhombus is a quadrilateral, meaning it has 4 sides, and each of the sides have to be congruent. So they have to have the same length for us to prove that it is a rhombus. Okay, so we have this figure here, and what they're asking us is to figure out if this is, in fact, if it is a rhombus. It's clearly a quadrilateral because it has 4 sides. Okay, so what you're going to do is you're going to find the distance from the A to the B, from the B to the C, from the C to the D, and from the D to the A to make sure that they're all exactly the same number. If they are all the same number, that means that it is a rhombus. Okay, so this one's kind of long. I hope I can fit it on this small screen here. I suggest that you pause the video for this one because it's not that it's a difficult problem, but it does take a couple minutes to solve. So go ahead and pause it and work it out. Okay, so I'm going to try to fit it all in one screen, I hope. I'm going to first find the distance from the A to the B. Okay, so I'm talking about from this point to this point, right here. Okay, I'm going to use my distance formula, and I've got to take the x. It's not x squared. I hope I haven't been saying that. It's x sub 2. X sub 2. And x sub 1, we're going to square that. So if I've been saying squared, I apologize. I mean subscript. And then I'm I'm just going to substitute my numbers in. My second x is the 2 minus a negative 1. Then I need to square that. And then I'm going to say 1 minus 0 and square that. Okay. All right. Remember to add the opposite. So 2 plus 1 is equal to 3. And 3 squared is equal to 9. And then 1 minus 0 is equal to 1. And 1 squared is equal to 1. So I've got 9 plus 1 is equal to 10. I can't simplify that because if I break it down, it's 2 times 5 is equal to 10. And that's about as far as I can go. So I'm going to leave it as the square root of 10. And I guess I could just remember that, or you guys will remember that. And now we'll go from B to the C. Okay, so this is not difficult, but it's a little bit time consuming when you have to check all the points. All right, so we've got x sub 2, x sub 1, plus y sub 2, y sub 1. And we're going to square that. Okay, I don't like drawing this long square root sign. I feel like it make it really messy, especially on my iPad. I'm drawing on my iPad, which is why it looks a little messy, or a lot messy. All right, so the second x, and the way that I'm looking at this is I'm saying, I'm like going in alphabetical order. So I'm saying that C is the second one. Let's do this. So we're going to do 2, and we're going to say 2 minus 1. Okay, we'll do it this way. So we'll do 2 minus 1. So we're going to subtract those x's. And then we've got to start with the same point. So you always have to come from, since I did this one first, now I have to do this one first next. And I hope that makes sense. So I've got to do 1 minus this negative 2. Okay? So I did 1 minus, this is the one, this is the negative 2 over here. So whichever one I make is like the first and the second, I have to be consistent with that so that it matches the subscript when I'm taking from the points. Okay, so we've got, here I'm going to add the opposite to make this a little simpler. 2 minus 1 is equal to 1, and 1 squared is equal to, 1 squared is equal to 1. Okay? 1 plus 2 is equal to 3, and 3 squared is equal to 9. And 1 plus 9 is equal to 10. So I've got the square root of 10, and so far from here to here is the square root of 10. So from A to B is the square root of 10, and then from B to C is the square root of 10 also. So far we are in good shape, and I'm going to erase all of that so that we do not get confused. Well, actually, I have no more room. So next up, I'm going to go from C to D. Okay, so I'm going to go from C to D. We're going to use the same exact formula all over again. X squared, or not x squared, x sub 2 and x sub 1. And then I've got y sub 2 minus y sub 1. All right. Okay, so I am going to enter my numbers in. Okay. I'm going to use for my x sub 2, 1 minus negative 2, and that's going to be 2 plus, and then I've got negative 2 minus negative 3, and I'll square that. All right, so I have to add the opposite because I've got a big mess with all these negative signs and subtraction signs here, and do the same thing with this one over here. And I've got 1 plus 2 is equal to 3. 3 squared is equal to 9. Okay, so I'm going to put this 9 down here and add them together. Now I've got negative 2 plus 3 is equal to a positive 1. And positive 1 squared is going to give me a 1. 9 plus 1 is equal to the square root of 10. So we are in good shape from C to D, and we have one more to prove. Okay, so far all of them are the square root of 10. Now we have to go from A to D. All right, so we've got A to D. Same formula all over again. I've got x sub 2, x sub 1 squared, plus y sub 2 minus y sub 1, and that's squared. Okay. So we have negative 1 minus negative 2, and we're going to square that. I've got 0 minus a negative 3, and I'm going to square that. Okay, we've got a bunch of negatives and subtraction signs, and let's just get rid of that because it is ugly and we have to use algebraic addition. So we will add the opposite and add the opposite. All right, so I've got a negative 1 plus 2 is going to give me a positive 1, and 1 squared will equal 1. And I've got 3 squared is going to give me, because I have 0 plus 3 is going to give me 3 squared, and that's 9. And thank goodness, our last one is also the square root of 10. So this proves that this is in fact a rhombus because we checked every single one of these side lengths to make sure that they're all exactly the same. Okay. So that's enough of the distance formula for now. We are moving on to the next point in our lesson, and let's see here. I'm just going to slide this over for a second because it looks like I just need to move it a little bit. Okay, that fits better on the screen. We've got midpoint next, and what we want to do is we want to find midpoint means exactly how it sounds. We want to find the middle in between 2 points. So middle means obviously that you are going to find the average, right? So we want to find the average of the distance. So I'm going to add the x's together, divide by 2, add the y's together and divide by 2, and that will simply give you your midpoint. Now just remember, you're not adding them together. You're actually going to put a comma in between because when you're finding the midpoint, you're finding a point. So when you add those x's together, divide by 2, it's going to give you one number. That's going to be your x. And then your y's, when you add them together and divide by 2, that's going to give you your y. And you leave them in a point form like a coordinate pair. Okay, so let's give it a try. We need to find the midpoint of the line segment with the given endpoints. So down here, they give us these endpoints. We've got 3. We want to find this guy right in the center here, and it's the point 3, 5, and 7, negative 2. So we're just going to stick it in the formula that you guys just wrote down in your notes. It's pretty simple. I love the midpoint formula. So we want to take x1 and x2. And when I say x1 and x2, I'm saying what I mean is x subscript 1 and x subscript 2. Okay, so we've got y subscript 1, y subscript 2. And we're going to divide that by 2. We're just taking the average of the x's and the average of the y's. So I'm going to use this 3 as my x1. And I'm going to use this 7 as my x2, or x sub 2. And then for my y's, keep that comma in between so you don't add them together or multiply them or anything because it's kind of weird to keep a comma in your answer, I feel like. So we've got, for our y's, we're going to use the 5, and we're going to use the negative 2. And we're not subtracting, so we're just going to keep that negative as a negative. Okay, so we've got 3 plus 7 is equal to 10, and 10 divided by 2 is equal to 5. And I'm kind of jumping ahead, but that came out so nicely, I just wanted to hurry up and get to it. All right, we've got x plus 5 plus a negative 2 is going to give me a positive 3 divided by 2. And I mean, you could just leave that as this point, and our book is leaving this as the point 3/2. We can leave that as an improper fraction. Or if you wanted to, I guess you could change it in a decimal, but normally we just leave it as an improper fraction. Okay, so the midpoint is going to actually be the point, the coordinate pair of 5, 3/2.